Problem 159. This is a very good example for linear momentum and impulse. So I would suggest to think about this problem at least for 15 minutes before seeing the solution in this video. So in this problem, we have this block, which is sitting on the ground, and we are applying force P, which is not constant. P is changing from 0 to 150, from 0 to 3 seconds. And after 3 seconds, it becomes 0. So the force is linearly changing over the first 3 seconds, and after that, it is 0. And we have all the information about friction. So in one point, after reaching to some specific force, or P, this block is going to start to move. And we don't know when it's going to start to move. We need to figure it out. And after that, we are going to have more force, and the force is going to go to 0. But after the force goes to 0, because this block is going to move, it's going to take for this block some time to stop. And the question is, after or in what time the block is going to stop. Okay, that's the question. So again, think about this problem, try your best, then see the solution here. So first of all, we need to figure out when this block is gonna start to move. So we need to draw the free body diagram. That's the first step. We have this force P, we are gonna have normal force, we are gonna have mg, and also the friction force. Because we are starting from the rest, the friction force is not gonna be equal to mu s times n or mu k times n. Friction force is gonna change depending to P, right? And by increasing P, friction force is gonna increase too. But in one point, the friction force is gonna go to mu s times n. And if P increases after that, the friction force is not gonna be able to tolerate it, so the block is gonna start to move. So first we need to find at what time the block is gonna start to move. If you look at force P from this plot, P is gonna be equal to 50 times T. That's gonna be the equation for the force. When T is between 0 and 3. After that, P is gonna be equal to 0. So sum of the forces in the x direction is going to be equal to 0 before starting to move. And let's say we are writing this equation for the time that it is about to start to move, which means the friction force in that time is going to be equal to mu s times n, right? So in the x direction, we are going to have P times cosine of 30 minus friction force, which is going to be mu s times the normal force, is equal to 0. And sum of the forces in the y direction is equal to 0 too. From here, we are going to have n plus P times sine of 30 minus mg is equal to 0. So from the second equation, we are going to find the normal force. Normal force is going to be equal to mg minus P times sine of 30. Sine of 30 is 1/2, and P is equal to 50 times T. So it's going to be 25 times T. And in the other side of the equation, negative 25 times T. That's the normal force. If I put it here, then we are going to have P times cosine of 50, and P is 50 times T, times cosine of 30, minus mu s times n, which is this, minus mu s times mg minus 25 times t. And again, t is the moment that this block is going to start to move. So let's say that time is ts, right? So in that moment, we are going to have this equation. So if you look at this equation, we have everything except ts. So we can find ts from this equation. We know what is mass, mu s, and everything. They are all given. the mass is 20 kilogram. So from here, TS, if you calculate it, it's going to be 2.02 seconds. So first of all the equations are correct because in all the equations they assume P is equal to 50 times T. It means that time should be less than 3. Otherwise, P is not going to be equal to 50 times T. And also, we figured out the starting time. So at this point, 2.02, the block is going to start to move. Now, after it's starting to move, at this point, P is going to go to 0, and in one point, everything is going to stop. Let's call that point T final. So this condition, or this point, I'm going to call it 1, and 2 means the final point after everything stops. Between these two, I can write the impulse linear momentum equation. Why I'm doing that? Because if you remember, in that equation, we have integral of sum of the forces dt. And if I have sum of the forces in any direction in terms of time, which I have it here, I can do that integral. So let's write down that equation. Based on that equation, in the x direction, I have g2 in the x direction minus g1 in the x direction is this, is going to be equal to integral from time 1 to time 2, sum of the forces in the x direction dt. Okay, so between 1 and 2, 1 again means starting to move, and 2 means when everything stops. What is G2? At the end, everything is going to stop. The block is going to stop here. So the linear momentum is going to be equal to 0, right? So this one is equal to 0. And G1, at the beginning, the velocity, the initial velocity is equal to 0 because it is just starting to move. So this one is going to be equal to 0 too. Now this integral. So this integral must be equal to 0, but sum of the forces in the x direction from here to here is going to be a different thing because we have that force P, and after this point, we are not going to have this P, and we are going to have only the friction force, right? So I'm going to break down this equation to two parts. From T1, which is 2.02 to 3 seconds, sum of the forces in the x direction is going to be P times cosine of 30 degree minus friction force, right? So I'm going to have P times cosine of 30, and P we know is equal to 50 times T minus the friction force. Now friction force, because it is slipping from here to here, the block is moving, right? And because of that, the friction force is going to be mu k times n. So we are going to have minus mu k times n. From this equation, we know n is equal to mg minus 25 times t. So this is the sum of the forces in the x direction times dt. Plus, from t is equal to 3 to the last time. So from 3 to the final time, sum of the forces in the x direction, again, is going to be P cosine of 30, but P is equal to 0 during this time. So we are not going to have any force for the from this P. The only force in the x direction is going to be just the friction force. So, and also the friction force is going to be in the negative direction. So we are going to have just negative mu k times the normal force. And the normal force after eliminating P, or after vanishing P, the normal force is going to be equal to just mg, right? So the friction force is going to be mu k times mg dt. So everything is going to be equal to 0, right? Because the other side of the equation is equal to 0. This integral, you have everything here, so we can calculate this integral. in this one, we don't know what is TF. So altogether, we are gonna have only one unknown in this equation, right? For the first integral, integral of 50t cosine of 30 dt is gonna be 1/2 of 50t squared times cosine of 30. And for the second part, negative mu k mg, we are gonna have negative mu k mg times t. For this part, again, we are gonna have 1/2 of t squared. So we have two negatives to get a positive. 1/2 of mu k times 25 times t squared. Everything from 2.02 to 3. Plus this integral, and that integral is going to be simply negative mu k mg times t, where t goes from 3 to the final point, tf, is equal to 0. So the rest is easy, right? So you need to replace t with 3 first, then minus everything when t is equal to 2.02 here. And same thing here, it's going to be negative mu k mg times tf plus mu k mg times 3. So we are going to have only one unknown in that equation, which I'll let you do the math. And at the end, tf is going to be equal to 3.69 seconds.